Hello, Calculus 12 students. I decided to go over the sample problem that was given out last class. The question was given out in the form of a discussion question, and I want to take this time and go over this question because it did take a little bit of time to figure out, and some students are still probably struggling to find out what this question is really talking about and what we're trying to find. So, based on the problem that was given to you, I gave you a situation where you have two linear lines. So here are my linear lines, one highlighted in yellow and the other one is highlighted in green. So I gave you two linear lines, and I also gave you this parabola here highlighted in blue. In this question, I also told you that the two linear lines, they intersect at the point 1, 8. And the equation of the blue parabola was y equals to negative x squared. Okay, so those are the types of graphs that were given to you in the problem. And then I asked you a series of questions like, what do you see, what do you know, and what are you trying to find? Okay, so after you kind of analyze the picture here, basically what I was trying to ask you to do was I was trying to ask you to find the equation of the two linear lines. So one thing that you have to notice about the two linear lines is that, yes, they do intersect at the point 1, 8, but both the lines, actually, they are tangent to the parabola. So they're tangent because they touch the parabola at one point. I'll call this point A. And the green line will touch the parabola somewhere over here. I'll call that point B. So for this question, your job was to find the equations of the two tangent lines. So the equation in yellow and the equation in green. Now the question was, how do you approach this type of a problem? Okay, so let me just kind of delete this green line here and just focus on the yellow line there. One thing that you have to recognize about the yellow line is the yellow line is considered a secant line. Okay, so the yellow line is considered a secant line because you know 2 points. You have the point A, and at point A, you don't know the x value and you don't know the y value. And you also are given this intersection point, which is 1, 8. So I'll call this point C. So since the yellow line, for the yellow line, since you know 2 points, we can consider that a secant line. Now, what's also interesting is that since the yellow line touches the parabola at one point, which is point A, the yellow line is also a tangent line. So one of the keys to this problem is that you need to recognize that the secant line is the same thing as the tangent line. Right? So if the secant line equals to the tangent line, then another thing that's true is that the slope of the secant line must equal to the slope of the tangent line. All right, so both those lines are linear lines, so if they're the same thing, then obviously the slopes must be equal. All right, so what you have to do next is you have to write an expression for the slope of the secant line, and you also have to write an equation for the slope of the tangent line. Now, going back to last chapter, if we were talking about the slope of the secant line, generally we call that the average rate of change. And if we're talking about the slope of the tangent line, we call that the instantaneous rate of change. So maybe instantaneous rate of change. Okay, so those are the English words that we use to describe the slopes of the secant line and the slope of the tangent line. Now, what we need to do next is we need to write a mathematical expression to represent the slopes of the secant line and the slope of the tangent line. Well, the slope of the secant line, that's just basically a rise over run situation, very similar to what you saw in Math 10. So I'll call this I'll call this I don't know, y2 minus y1 over x2 minus x1. So that is an expression that you can use to represent the slope of the secant line. Now, what about the slope of the tangent line? Well, the slope of the tangent line, by definition, we call that the derivative. All right, so the slope of the tangent line is basically the derivative. And basically, since we don't know, the equation of the yellow line, but we do know that if we focus on the parabola right here, we know that the yellow line is tangent to the parabola at point A. So at point A, the slope of point A is the same thing as finding the slope of the parabola at point A, which is the derivative. So if I know my equation of my parabola is y equals to negative x squared, the derivative of negative x squared is just negative 2x. Okay, so just highlighting this right here, the derivative is the slope of the tangent line at that point A. So this is the mathematical relationship that you can set up once you understand the slope of the secant line and the slope of the tangent line. Alright, so after that, you need to kind of solve this, but you can't really solve this just yet because you need to put some more information into this mathematical expression. Now in class, I also told students that this may help, so I'm just going to slightly change my notation here. Instead of saying y2 minus y1, I'm going to use, I'll say y minus y1, and I'll change x2 minus x1 to x minus x1. Which is the same thing. I just kind of slightly changed the notation to help a few students here. And I'm just going to delete this point here. I don't know what this point is, so I'll call this question mark, question mark. So based on going back to this expression right here, is there anything you can do to this expression so that you can kind of move forward with the problem? Okay, well, since the slope of the secant line, we know a point on the for the yellow line, we know the points 1 and 8. So what I told students is that if you have the point 1 comma 8, you can actually substitute those points into your slope here. So this will be y minus 8 over x minus 1. All right, so that's simply just inserting the numbers into your slope. And that's going to equal to, just one second here, erase that, and that will equal to negative 2x. Now the problem is you still need some more information to kind of move forward with this problem here. And then what I told students is that if you look at this y right here, this y minus 8 divided by x minus 1. If you look at that, that y that's highlighted in yellow there, is there anything else that you can use in your diagram to kind of help you out? And what I told students was that, and some students saw this right away, and if you go back to your original parabola here, which is y equals to negative x squared, you'll notice that this y value right here represents that y right there. So what you can do next is you can substitute the y's now, and this would give you negative x squared. Okay. So hopefully that makes sense, because the negative x squared, that tells you the y value for any given x on that parabola. Okay, and then there you go. There is your mathematical expression there. You have a rational expression here, and basically what you need to do is you need to solve this. You need to solve this rational expression right here. And when you solve this, you have to ask yourself, what are you solving for? Well, if you solve this rational expression, you'll notice that you're solving for the variable x. So let me just go back here. You're solving, yeah, that's right. So if you solve this, you're actually solving for the variable x. So you will get answers for x, and then you have to ask yourself, what does x represent? And that's another key to this problem. So once you solve this, ask yourself, what do the answers represent? And the answers represent the x values where the slope of the tangent line is negative 2x. So let me just kind of repeat that one more time. If you solve this rational expression here, the values of x that you get, they have to satisfy the slope where it's negative 2x. So where is the slope negative 2x? Well, let me just erase this whole graph here. And since my parabola is y equals to negative x squared, the values of x will satisfy the parabola where the slope equals to negative 2x, and you only have two values of x where the slope is equal to negative 2x. So over here you'll have these x values. So once you solve this rational equation here, that will tell you the x values where the parabola has a slope of negative 2x, which are these points right there. Okay. So I think most students are okay with solving the rational equation, but you have to understand what do your answers represent, and they basically represent those two x values at the point A and the point B. Okay. All right, so let's just delete all this again, and now let's solve this problem now. In order to solve this, I told students to use some cross-canceling here, or a cross-multiplication here. So this would be negative x squared minus 8 equals to negative 2x times x minus 1. All right, so this is something that we did in the first chapter pre-calculus. You just take your denominator and just move it to the top right, and then you just simplify. This is negative x squared minus 8 equals to negative 2x squared plus 2. And then I'm going to take everything on the right hand side of this equation and move it to the left hand side. So this will give me x squared, this is supposed to be plus 2x, I believe. So this will be negative 2x and minus 8 equals to 0. Alright, so that is a parabola. Let's solve this. This will be x and x. This will be plus 4 and minus 2. And then this will give me x equals to, no, sorry, I made a mistake again. Apologize for making that mistake. This is going to be negative 4 plus 2. So my x values will be 4 and negative 2. Okay. So sorry about that. I made a few mistakes there, but hopefully I'll try to avoid the mistakes from now on. Okay, so I have I have 4 and negative 2. So what that represents the x values where the derivative is equal to negative 2x. And if I look at my parabola here, those are once again the x values of here and here. So I'm assuming this will have an x value of 4. And I don't know the y value, so I'll put a y value there. And this has a value of negative 2 and a y value that I don't know. And I'll call this maybe y3 and y4 because they are different y values. Okay. All right, so let's go back and let's try to kind of solve this problem now, because once again, the idea for this problem is that we want to write the equations of the two tangent lines. So let's work on this first tangent line, highlighted in yellow, and once again that point is 1, 8. So the question is, are you able to find the equation of the yellow line? And the answer is yes. You now have enough information to find the equation of the tangent line. And if you want to find the equation of any tangent line, the general equation of the line will be y minus y1 equals to x times x minus x1. Okay. So there are several ways to approach approach this problem now. You could use point A, or you could use point, I'll call this point C. It doesn't matter if you use point A or point C for the value of y1 and the value of x1. It doesn't matter, you will still get the same answer. The problem is you don't have this value of y3. Now if you want to get that value of y3, all you have to do is you want to take this value of negative 2 and you want to insert that into the parabola right here. Okay, so if I do that, if I know that my equation, my parabola is y equals to negative x squared, and if I know that the x value is negative 2, this will be negative 4, so this will be negative 4, so this value right here is actually going to be negative 4. Okay, and then you simply get that by just inserting this negative 2 back into the parabola. Now, you didn't actually have to do that. I know some students in the class went on and found that value, but you don't actually have to do that, because you could also just use the point 1, 8, because 1, 8 is also a point on your linear line. I'm going to go ahead and just use the point 1, 8. You could use 1, 8 or negative 2, negative 4. It doesn't matter. You'll still get the same answer. So let's go ahead and just insert 1, 8 into my equation here. So this will be y minus 8 equals to, and once again I made another mistake here. This is actually supposed to be m. So I'll put m here, and this is going to be x minus 1. Okay, so we're almost done. All we have to do now is we need to find this value of m. And what's that? That's actually the slope of the yellow line. Now, this is another area where students were having problems because they didn't know how to find the slope. Well, there's two ways to find the slope. Well, since you have the 2 points A and C, you can simply do like a rise over run. You can simply calculate the rise over run, or you could use the definition of the derivative or your derivative rules, and you can notice that the slope of the yellow line at point A will follow the power rule of y equals to negative x squared. So if I have y equals to negative x squared, I know that y prime is going to be negative 2x. And the point that I'm interested is the point A. So if I find, sorry, the x value of point A is negative 2. So if I plug in negative 2 in for x, I can find the slope at point A, which is going to be 4. Okay, so this is my slope right there. That's going to have a value of 4. So I'm going to delete that and now plug in 4. And there you go. I now have my first equation for my first tangent line. Now I'm just going to erase this. And I'm just going to go ahead and just simplify this line here. So this will be 4x minus 4 plus 8. And this will be y equals to 4x plus 4. So that is the equation of the yellow line, and that's the equation of the tangent line. So for this question, you definitely needed to think about this question, because there were definitely many different parts. You definitely have the tools to solve this problem. It's just that you need to make the connections between the slopes of the secant line and the slopes of the tangent line. Alright, I'm going to go ahead and just solve the equation of the other line now. I'll do this one a little bit more quickly now because it follows the same pattern or the same procedure as the previous problem. So writing out my equation, my line here, I have y minus y1 equals to m times x minus x1. And let's insert y minus 8 equals to m onto x minus 1. Alright, so once again, I'm just simply putting these values in for here. And now I need to find the slope of the line, the green line, m. And once again, I can definitely use the power rule one more time here. If I use y prime, this is going to be negative 2x. And the x value that I'm looking for now is the 4. So this will have a slope of negative 2 times 4, which is going to be negative 8. So that means my slope here is going to be negative 8. And all you have to do now is just simplify your equation, and then you're all done here. So this would be negative 8x plus 8 plus 8. This would be negative 8x plus 16. And there you go. That is the equation of your green tangent line. Sorry, that's 16 right here. Alright, so there you go. That's what we covered last class. It did take a fair bit of time. Please don't be alarmed that if you weren't able to solve the problem quickly, please do not worry. I was telling some students that in the AP class, it did take a long time for students to solve this question as well, and I recall only one student was able to come up with it after half an hour of thinking and trial and error. So yeah, this question, initially when we first see a question like this, it does take a little bit of time to kind of figure out what's going on. Alright, so once again, I apologize for all the small errors that I made in this mistake, but in the end, I think I was able to give you guys the correct answers, and then now you can try the questions in your homework. Alright, I'll see you guys in class.